So, hey Mike, how are you? We're going to talk about open storage systems on industry standard hardware. So, storage is a bigger and bigger expense in everybody's budget these days. And I'm going to talk about a different way of doing it that is more popular than you might think. So, what we're going to go over is what the open storage advantages are, what I mean by it, some of the hardware and software that goes into it, and some of the use cases, as well as some example pricing of what it's involved. There's an Open Storage Summit a couple times every year. I went to the last one earlier this year, which was in Amsterdam, so this is an international effort, and there's a lot of different organizations that are involved in it. So, what is open storage? Well, it's enterprise-class shared storage on open architecture with open source software. Just like Red Hat provides a supported version of open source software, there's lots of other different supported open source softwares out there. Using industry standard protocols and industry standard hardware. And this is not a proprietary storage system. And to back up even further, why shared storage? Some organizations don't yet have shared storage. They have what we still call direct attached storage. So servers with hard drives in them, and they might or might not have virtualized servers. Those operate on internal hard drives. But there's a lot of good reasons to have shared storage. First of all, the more and more stuff that you store, you're going to want to be able to centralize, administer it, and do backups from a central location. You need high performance for virtual servers and for databases and things like that. So when you can spread those storage writes and reads across multiple spindles or across SSD drives, you can get much better performance. Disaster recovery, one of the big things that you want to do as an IT person is keep your information, keep your records, keep your stuff, don't lose any data. And just almost as important as don't lose any data, keep your systems up and running. So by being able to have all your information that's stored in one place, make a replication of it to somewhere else where you can then turn your systems back up is pretty important. Video surveillance storage. There's an explosion of video, whether it's surveillance cameras. Talk to organizations that have hundreds of cameras, and they need a place to store all the video surveillance. And some of them say, well, I've got a little bit of extra space on my primary storage, and they store it there. And so there's many different classes or levels of storage, whether it's tier 1, tier 2, or tier 3, and they're not all as important as each other. And then just general file system storage. Stuff builds up over time. So there's good reasons to have shared storage. Now, for a long time, using the legacy storage model, it's been delivered as software, hardware, services, and support all in one proprietary system. And when storage first started out, some of the big companies in the industry, or EMC, the NetApp, and Hitachi Data Systems, to ensure the reliability of the data and to make sure that it could be accessed quickly, this was the only way to deliver a system that was reliable enough for people to work on. But there's a new storage model. The new storage model is, just like you run application software on standard operating systems and standard hardware, you can do the same thing with storage. Enough of the protocols are out there, there's enough file systems and support and different ways of going about doing things that this is a very viable way of doing it. And if you look at some of those companies that used to make mainframes, or the companies that used to make phone systems, that was their way to go to market as well, proprietary systems. But that's not how we do things anymore. We don't buy our mainframes from Wang. We don't buy our phone systems from Nortel. And in the future, we may not buy our storage systems from people that only offer proprietary offerings. So, what does open storage provide for you? Better performance, and I'll show you why it provides better performance. A lower price, no vendor lock-in, no forklift upgrades, and support choices. So what are the different elements that go into that? Well, we got our storage controllers, we got our hard drives and SSDs, we've got our disk shelves, got our software, got our installation services, and support, all running over standard protocols. And so a typical storage controller would be a 2U Intel server, or based on Intel processors. And for the ones that we've used, we like 2U servers because they provide enough PCI slots for the host bus adapters. We put 5 channel cards into them, or 10 gig Ethernet cards, or host bus adapters to connect to the external disk shelves. And the newer storage software can actually use the memory in them to cache. Right now, that caching per read is about at 256 gigs, but most of these servers can go up to 768 gigs of memory. And if all that can be used for caching, it's very effective at delivering information quickly. Hard drives, most people know who the major hard drive manufacturers are. Hitachi, Seagate, Western Digital, folks like that. You open up a proprietary storage system, and or if you take delivery of one, you're first of all going to see the controllers that look like standard x86 servers. You're going to see the hard drive shelves. You're going to see the hard drives from the standard manufacturers. And you're going to see the interconnect between them, which is going to be SAS cables. There's a big trend towards solid-state drives as well. So SSDs are based on the lithography. The price of SSDs are based on lithography of Intel and Samsung, and they're driving that constantly lower, just like processors follow Moore's law, where you get more performance at lower cost. SSDs are able to give you that as well. So in some cases, people are looking at all-flash arrays for high-performance systems, or they're using SSDs to accelerate reads and writes. Hard drive shelves, these are pretty simple. Think of a server without a motherboard in it, and some backplanes that are able to access all the drives and provide multiple parallel paths to the hard drives externally. And to get reliable enterprise-class storage systems, you don't want a single point of failure. So the disk shelves that we recommend have dual power supplies, dual controllers, and just multiple paths. If you can design things so that you don't have to call support when you have the failure of a single component, or you don't have to call them and say, my system's down, it's much easier to go through and replace that one component that's failed, as opposed to have to hurry up and fix an entire system. And these come in typical, different sizes typically. So when I say a performance shelf, usually when we want a high performance system, then I divide it into performance and capacity type systems. Performance is for like virtual servers or virtual desktop infrastructure or online transaction, where it needs a lot of IOPS, and it needs a lot of IOPS quickly. So we tend to use 10K RPM drives, 300, 600, or 900 gigabytes on these. And so this shelf will take 24 of them. We can also put in the 2.5-inch SSDs in this type of shelf. And you can see on the back, it's got the redundant power supplies and redundant controllers. We still use 3.5-inch drives too. These come in 1 to 4 terabyte sizes. So when you start to get up to the 100 or 200, 500 terabyte large capacity storage systems, these 3 terabytes and 4 terabyte drives are really the right size for this. And so this shelf can hold 16 drives, and then this one can hold 60 drives. So there's a few different versions of a 4U high shelf that can hold 60 drives. But if you start calculating out, you say, well, 60 drives times 3 terabytes, what do we have? 180 terabytes. We do 1, 2, 4 of these. You can see how you can get up to higher capacities pretty quickly. And these all use standard protocols. The proprietary storage systems use a lot of these standard protocols as well. I mean, there's only so many ways of accessing a hard drive. You got SATA, you got SAS. That's pretty much it. And for block level access from the servers to the storage system, you've got iSCSI, you got fiber channel, you got fiber channel over Ethernet. From file level access protocol, you got mostly NFS or SIPs or SMB. And then the protocols that goes between the controllers and the disk shelves is SAS. Right now it's SAS2, which is each SAS cable carries 4 channels of 6 gigabit per second, so 24 gigabits per second. And the new protocol is SAS3. We've got some cards like that in our lab. That's up to 12 gigabit per second per channel. So this is fast. And it can address somewhere, depending on the device, somewhere between 256 and 1,000 disk drives. So you can set up these large SAS sleuths and drive large shelves full of disk. And that's all that the proprietary storage system guys do it as well. We even can, if you stop by our booth and see the demo of the system, we can show the environmental monitoring of all the drives and the fans and the power supplies and everything through it. So let's talk about storage software. So we've got the hardware figured out. It's all standard stuff. It's you can get it from a number of different vendors. It's tested together. But what about the software that we're putting on this thing? Okay, it's the big difference in the storage system, and that's the true value of a lot of the proprietary storage system vendors. I mean, EMC has their Flare or their Isilon or Symmetrix. that operating system and file system. NetApp has ONTAP and Waffle. Dell has the Fluid file system. They all have their own well-tested software that works in conjunction with their hardware. But let's talk about what the supported open source alternatives are. So before we talk about the specific open source software, let's talk about some of the features that we're going to want in storage software. As time has gone by, it's gone from more just, we want to store stuff and get it back, to we want lots more features. We want to be able to have a reliable operating system, a reliable file system. We want to be able to do snapshots. So if someone deletes a file, we can go back to a previous point in time and recover that file. We want to be able to replicate the information from one location to another. Compression. Sometimes if there's things that can be compressed, or deduplication, we'd like to have that. Encryption would be nice. Really fast reads and writes. So normally the way that if you need faster reads and writes, sometimes you just have to add more disks so you can spread those reads and writes across more spindles. If there's ways that we can do that differently, by either compressing the data so we read and write less, or using memory or SSD to cache it, then we want to be able to do that. High availability, we want to be able to design so for no single point of failure, and then hypervisor and other application integration. So, open storage software. A lot of it is based on the ZFS file system. This file system that started development back in 2001 at Sun Microsystems. Of course, Sun Microsystems was bought by Oracle, and Sun developed, I don't know if you remember, but Sun developed NFS. And that was the network file system that they developed back in the early 90s, and they put it out there as an open standard. They did the same thing with ZFS. In fact, when Oracle bought Sun, the ZFS and Solaris was turned into an open source project. So a lot of people that had worked on these projects at Sun Microsystems went to work for other companies, but they also continued to work on this open source project. Their current project is called Lumos. There's a distribution called Open Indiana. And then there's some free projects based on this, one called FreeNAS and one called NAS for Free. Of course, you can also use Linux or FreeBSD as just a regular file server by just sticking a RAID card in it and using the normal protocols of Linux or FreeBSD. You can even do the same thing on Windows. It's not really open source, but you can do that. Red Hat has the GlusterFS storage server, and then OpenStack is another way of doing storage. So there's a lot of flat-out open source storage software out there. I don't really like to run open source software on my customer that's just supported by community support and things like that. So we look at the commercially available versions of this open source software. And those add a lot of the things that you might want from a regular software package. So just like it's fun to turn up CentOS Linux on a computer system at home and play around with it and learn how to use Linux. If you're going to go into production on a database and you need to have that up and running, you can get a Red Hat version of Linux, so you can get support from Linux. So Nexenta is the leader in providing ZFS. They work on the original Solaris. OS Nexus does a version on Linux. SoftNAS does a version on Linux. And there's also a version of Red Hat with their GlusterFS, and Microsoft has their Windows Server storage system. So, ZFS being the file system of choice for this type of setup, let's talk a little bit about why I think and why other folks think that it's better than other storage file systems out there. So, first thing is, as drives get bigger and more data is out there, there's a possibility of losing data or having it corrupted. So, if there's a power loss, or if there's some kind of electrical spike or things like that, the data can get corrupted. So ZFS from the get-go was designed to not have any data corruption at all. And that's because it writes the parity information at the same time as the actual data itself. Now for performance, it's got a hybrid file system. So instead of just reading and writing from the disk, and to get better performance you have more disks, it actually caches on reads in the memory, so it can use up to 256 gigs of DRAM for caching in the memory right now. And then if your working set size, the amount of data that you need to cache is bigger than that, you can add SSDs, usually in 200 gig increments, to cache for that as well. Now, when you write, a lot of times when you applications want to have synchronous write, which means they want to have an acknowledgement back from the storage system that the information that they sent was actually collected, put in non-volatile storage, and is not not going to be lost. So we can use SSD or SSD-backed DRAM for synchronous write acceleration. This is a mature system, been around since 2001, so it's been around for more than 10 years, which is typically how long it takes to get a file system working and running well. And parity is done in the main processor, so as Intel processors get faster, we can do compression and deduplication and parity much more quickly. So a standard RAID system is going to have RAID 0, RAID 1, RAID 5, RAID 50, RAID 10, and those are all standard things that are done in hardware cards. Well, we can do the same thing, we can even do it better. So we write the parity and the data at the same time, and we can do mirrors, we can do 1-disk parity, 2-disk parity, and 3-disk parity. And the importance of 3-disk parity is for the really big drives, because once you start getting above 2 or 3 terabytes, and if you lose a drive and you have to rebuild all the information on it, it can take a day or two to rebuild the information. So you might lose another drive within that set, and then all of a sudden, what do you do? So that's why 3-disk parity is important. ZFS has a lot of different things that will make it unlimited. It uses copy on write, so it can have unlimited size, it can have unlimited snapshots, it can have unlimited replication. It has data integrity, and it just works really well. I'm not going to go into a lot of the technical details. This is a demonstration of the hybrid storage pool. So we try to get the data that the system thinks is going to be required into the memory. That's the adaptive replacement cache. The level 2 adaptive replacement cache is the SSDs, so we can expand it using that. And then our main pool is our hard disk drives, and then our intent log, that's for our synchronous write. So what we can do is set up different storage systems based on what you need from a cost and performance standpoint. So if you just need a bunch of storage, bulk storage out there at a low price, we do minimal. Okay, so we'll set up hard disk drives in the main pool. That's what we'll typically do for a capacity storage system. If you need to store video surveillance data, let's get 10 or 12 or 16 or 60 of these 3 terabyte drives, set them up as a RAID Z2 or a RAID Z3 system, and just read and write. If it turns out that you need to do video analytics, or you need to store it faster, or you're using this as a backup system and your backup window is getting compressed, we can put SSDs in there to accelerate it. So we can put write SSDs, like under good, under better, we can put read SSDs. And then if we're going to make an all-flash array, which we can do with ZFS storage, we'll do SSDs, and that's all we're going to use. So it gives us the ability to put together some specific tested systems for different applications. And here's just a visual of the different hard drive configurations. So we've got RAID with 1-disk parity, RAID Z2, which is 2-disk parity, RAID Z3, which is 3-disk parity. We can put those parity groups into a pool and write to them. But for fast performance, we typically do a pool full of mirrors. This is what we'll do if we're going to use virtual servers or virtual desktops or things like that, because it really speeds up the read and write. There's a trade-off between usable storage versus raw storage, depending on how you set things up. Snapshots and replication, they're done quickly, they're done accurately. We don't need to go into the details of that. This was an interesting one because the working set size is kind of what's important, and this gives you a visual of the relative speeds. So the ARC is the memory. So if we store things in memory, we can access it really, really fast, and we get IOPS in the millions. Layer 2 ARC is SSD. We get a factor of 10 less than that. And then if we have to go to the disks for read and write, it's a bit slower. But this is why I say that ZFS-based file systems can perform much faster than traditional proprietary storage systems because of the hybrid storage. In fact, this line here, this red line here, is 10 gigabits per second line rate. So you can see that if our working set size is small or we have lots of DRAM to cache, we can get really fast performance. So even though we position this mostly under tier 2 storage to start by storing bulk data and things like that, there's no reason that this can't be used for high-performing virtual systems or virtual server systems. So ZFS is the open source file system. To give you an example, Nexenta is a company that created Nexenta Store. So this is a commercially supported version of ZFS. And this kind of shows you what they add on to it. They add on the additional way of being able to upgrade it quickly. And then they add fiber channel driver. They had high availability clustering. And they had 24/7 support and all sorts of other things like that. So it takes it from an open source project that works well, where people in an organization will have to support it themselves. And some service providers run ZFS internally, but they have a team of people that understand this stuff. Most of our customers don't have a team of people that can be ZFS storage specialists on their staff. So we end up using a commercially supported version where everything is tested and there's a hardware compatibility list. And just like there's a trend from proprietary storage systems to hardware running software, there's a trend for using SSDs. And so Nexenta has certainly worked to contribute back to the ZFS organization things that will improve the SSD performance. Okay, so what kind of different use cases might we use this for? When you say storage, it's kind of a general idea, and you think, well, where am I using storage now? If you have a big box of disks, some kind of storage array, whether it's an Echologic or an EMC or a NetApp, Propellant, or Hitachi Data Systems, or 3PAR, or IBM, those are all existing storage systems, and if you look at the hard drive size on them, you can probably tell by the hard drive size how old they are, whether it's 300 gig or 120 gig or 73 gig or maybe all the way down to 9 gig drives. At some point you're probably going to have to upgrade that storage system. We've talked to a lot of K-12 and higher education organizations that they're looking that they need to have 100 to 200 terabytes of storage over the next couple of years just to store all the videos that they're using. But backup and archiving, video surveillance storage, document imaging, unstructured data, and if you're going to have a one-on-one computing initiative, maybe you want to offer storage to your students, maybe you want to pay for that storage in the cloud, or maybe you want to do an internal Dropbox. This storage is what enables that type of thing. And then tier 1 storage, virtual servers, virtual desktops, high-performance databases, online transaction processing. As these get bigger and more complex, the performance for that is necessary as well. Yeah, Steve?
Yeah, just want to bring up, there's a school district that, and you guys probably get this a lot as well, is they'll give you over the summer and say, hey, we've got 4 or 5 different servers that we need you guys to install. Here's the specs for them, right? You got an Oracle database you need to have, minimum specs of this many reads, this many writes, this much memory. This one particular school district ended up having to buy 2 different shelves because he needed something that had 15K drives as opposed to something that he only needed 10K drives. So he ended up having to buy 2 different shelves just to make this thing happen. And you can imagine from a proprietary perspective how much that would have cost. So just wanted to bring that up because these guys do get these mandates pretty much, and they are mandates pretty much part, right? You might have the VMware environment, but you don't have the disk requirements that you're looking for. So disk and scale, I guess, is what we're trying to get at.
Yeah, we get that, and we do a lot of voice systems in some cases. To upgrade from non-virtualized to virtualized voice systems, the requirement is to have fiber channel connected storage with a minimum amount of IOPS. And even though most people have storage systems in place, they might not have fiber channel connected systems, or they might not have the available IOPS performance. So we can put a starter system in like this and then grow it over time. So there's a lot of flexibility that we have. So one of the use cases is just network attached storage. You need more file system storage. People have their public shares or their private drives or things like that. They like to do images and videos and backups and store them. So this is great for that. We connect right with SIPs or SMB. We can connect into Active Directory and map permissions to the different folders, or we can use NFS version 4.1. We can compress inline, we can deduplicate inline, and then we can set high parity, and then we can do snapshot replication to copy it to another location. Backup and recovery. Most people have converted away from backup to tape. Some of that's still out there. We might want to be able to back up all our information and then replicate it somewhere else. So this works great with a number of different backup applications, whether it's connected by SCSI or Fiber Channel, or again, NFS or SIPs. Video surveillance storage. So I was working with a company and they said, well, we got 50 cameras right now, we're going to go to 200 over the next couple of years. We need to be able to store, because it was a manufacturing company, they manufacture tractors. We need to be able to store 24 hours a day, 30 days of video for 50 cameras. So there's a typical way of doing video surveillance is using a few different protocols. And so I calculated out that it was about 20 terabytes per 100 cameras per 30 days, which is a really rough number. It might be a little bit more, a little bit less. We were able to put together just a small single box starter system for them, and they didn't have to use, again, their main storage for that. Virtualization storage. Well, I talked about some of the performance enhancements on read and write that you can get with ZFS. And this is very important for being able to have fast performance on virtual servers or on virtual desktop infrastructure. You need to be able to boot the stuff quickly, so you need to be able to have a lot of IOPS in the morning when people come in. Professional services, certainly an important part of this. So one of the things that we do is we come in and we analyze what you've got, and then we come in and set the system up initially, make sure everything is running, convert over some of the data, and then show you how you can use it. And just like with everything else that our organization does, we don't leave you hanging. We offer support on everything that we sell. So you've got a lot of different support choices with open storage. You can get support from the organization that put it together from you. You can get support from the organization whose the elements are made up. So whoever the servers are made from, that's going to have warranty. The drives are going to have warranty. You can get support from the software manufacturer that provides the commercial version of the software. You've got your other types of support. If you don't like that organization, like ZFS, it's open architecture. If you don't like that version of ZFS from that supplier, you can switch to another version of ZFS. It's all the same. Everybody's using version 28 of ZFS now. So all the metadata, all the information necessary to be able to get the information from those hard drives is in the hard drives themselves. So you can take those hard drives, attach it to another server that runs ZFS, running Linux or FreeBSD or some other version of this, and continue to use it. You can't do that with a proprietary storage system. You can't take a NetApp shelf and plug it into an EMC controller and just get all the data off it. Right? I mean, you wouldn't even think of doing that, but you can do that with open storage architecture. And you can go all the way to self-support or community support. So here's some examples. So this would be like a small capacity system. So a server and an external disk shelf. 16 3-terabyte drives. That's the marketing number. They're actually 2.73. So it's about 44 terabytes of raw storage. Installation support. You really start to see benefits in performance and price with open storage as you get above 50 terabytes or 100 terabytes. When you're down at the lower sizes, the price for open storage systems compared to proprietary systems is about the same. So you don't save any money doing that because I'm not sure why that is. Maybe it is because the proprietary storage guys want to get you into an architecture and then have you upgrade from there. I don't know if their upgrade costs or support costs are more than the initial step-in costs, but in some cases I think they are. But this is an example. So we have high availability controllers and 4 shelves. This gives us 175 terabytes of raw storage. If we set it up with 3-disk parity, we get 120 terabytes as a usable rate. Price on this is about $120,000, give or take, from a typical vendor like us or anybody else who's doing this. If you get into bigger systems, it depends on what you're going to need. But this is a system that we put together as a design for a customer. It ends up being almost a half a petabyte of usable storage. You can start to see that you get down in the price. So it's $320,000. Right? So your price per terabyte goes down just because of the nature of the software price and things like that. And we actually put this design together for a customer. They had actually 1.5 petabytes. I would have liked to have sold it, but they ended up not making a decision yet. This was 1.5 petabytes. They're converting from tape backup to disk backup. And you think of what a 1 petabyte system is going to cost from a traditional storage vendor, I tell you it's going to be more than $650,000. So, and then on the performance side of things, it actually looks a lot more expensive. So when you're talking with people about storage, say, okay, well, what do you need? What kind of performance do you need? Is this primarily to store lots of stuff and get at it slowly, or do you need really high performance? Reliability is kind of a given. So this is a system that we installed at a city down in Florida, and they were converting to Hyper-V on everything. So this was iSCSI Access. And this was about $130,000 for, again, high availability, but these are using the 2.5-inch high-performance drives accelerated by SSDs on both read and write. So it gave us about 36 terabytes of usable storage. I think they're starting out doing about 50 virtual servers on it, planning on going to 100 to 150 over the next few years. So, our company, ICAP Network Systems, the specific storage systems that we put together, we call them SwiftStore. We've tested them in our lab. We have specific hardware, specific design, specific software. And so by doing these very specific designs, we know what kind of performance that we're going to be able to get and are able to support them quickly and well. So if you were to get a standard storage system from us, open storage system from us, I encourage you to continue to get support and buy the additional equipment from us. But since it's an open storage system, you can end up going and getting the hard drives and the disk shelves and the storage from other people in the future if you wanted to. So sometimes it's easier to get a system in place if it's easier for the customer to leave you. Any questions on this? All right, well, we got our booth up in the 200 row. We've got our demo system of SwiftStore. I can show you what the interface looks like. Show you how to set up drive pools, file systems, block storage, access it from a Windows computer.
Yeah, she'd like to see it, but get out and show it.
Not that we did it before.
We'll be here tomorrow morning too. All right, thank you. Appreciate it.